Now you trip over one of the design mistakes in almost every programming language on the planet that most computer scientists refuse to acknowledge as a design mistake, but which Python 3.0 actually fixed. What is 4 divided by 2? Okay. What is 5 divided by 2? 2.5. Right. To everyone on the planet except a computer scientist. A computer scientist says 5 is an integer, 2 is an integer. 5 divided by 2 is 2. And we throw away the remainder. Never mind everything you learned in grade school. Never mind those years we spent teaching you fractions and rational numbers. Right? They were all confused. It's easier for me to build hardware in which integer divided by integer is an integer, and it's faster to calculate that, so that must be the right answer. Okay? The source of many bugs in programs. And almost every programming language on the planet does what's friendly for the hardware instead of what almost every human being on the planet has learned in grade school. I don't know if they do this here. L for loser. Okay? Python 3.0 and 3.1 fixed this. In recent versions of Python, not 2.5, 2.6, 2.7, which is what we're using here, but in 3.0 and higher, if you take two integers and the result is exactly an integer when they're divided, you get an integer result. But if there's a fractional part, it gives you back the floating point number that God intended. 5/2 is 2.5, because that's what human beings, as opposed to computer scientists, expect it to be. Okay. So what I have to do here is somehow convert one or the other of these to a floating point number, because if either argument to division is a floating point number, Python returns a floating point result that says, oh, right, you must really want the fractional part. Okay. So let's come here and let's do float of len of values. Float is a function that does exactly what you would expect. It turns a number into a floating point number. Okay? Good. No output. So that means that all of those assertions passed. None of those cases failed. Okay? 3 lessons to take away from this. Then we'll have a brief preview of tomorrow, and I'll give you your homework for tonight. That's the quietest. Yeah, thank you. Thank you. Okay. You're not English, are you? No, the one who said boo.
Yeah, I'm English.
Are you? Yeah. Really? Because I was expecting the English would just grumble silently. Okay. Whereas the Scots right now would be throwing things. Right? And the Irish would be saying, if we get him drunk, he won't remember. So, lesson number 1 goes under the heading Test-Driven Development, TDD. We're going to be doing a lot of this tomorrow, but now you've had a taste of it. Before you write your function, write your tests. Number 1, it forces you to think about how you're going to test it. In fact, whether it's even testable before you commit to code. All too often, people will build software and then go, right, now, how am I going to test? I have no idea how I'm going to test this. Right? So they put in a lot of work and they've painted themselves into a corner. If you force yourself to think up front about how you are going to test it, lo and behold, and again, Hacker Dogmas and others have shown this, you will write more testable code that is easier to test, because it's uppermost in your mind. Right? You're thinking about how will I tell if it's correct actually helps with the correctness. Right? You've had to think through a few cases and decide what the right behavior is before you get the code down. Okay? So that's lesson number 1 to take away from this. It feels backward, but the way most good programmers are working today, certainly in the open source world, which is where we can get the most data, write the tests, then write the function that makes those tests pass, and then look at it and clean up the function once it's running. Okay. Red light, green light, refactor is the acronym. Write the tests, run them, you get a red light. Tests do not pass. Right? Write the function that makes the tests pass. The light comes green. Tests are passing. Good, you are done. And then refactor. Look at this and say, okay, now it works. can I speed it up? Can I clean it up? Is there anything else I can do? Now that I've got a working version that passes all the tests that I can compare it to, so that I can make little incremental changes and make sure I'm moving forward. That's the cycle you want to be in when you are programming. Red, green, refactor. Over and over again, and you want to make that loop really tight. Write a small number of tests. Write the code that makes those tests pass. Check that they pass. Clean it up a little bit. Add a few more tests. Okay, good. Some of them are failing. Right? Extend or fix the function so that those tests pass. Clean up what you've just done. Around and around that loop. As tightly as possible. That's what good programmers do. And if you do that, you will be a better programmer. Everybody okay with that? Okay, thing number 2. Notice that when all of the tests pass, it's silent. That's really important. If I was printing out test case 1 passed, test case 2 passed, test case 3 failed, test case 4 passed, test case 5 passed, and there's 100 test cases, you will probably not notice the failures.